So, what do I actually do at work as a data scientist, or let me be specific, as a product data scientist? Most of my work, or actually now 100% of my work, done on this laptop. Before we could have meetings one-on-one, but now because of the current situation that we live in, and also because we're going to the work from anywhere idea where you don't have to be in the office and you can permanently work from home, I have to constantly stare at my screen. That's great, it gives flexibility, but also it takes away the ability to see real world things, and everything you do is in the screen. But let's start from the beginning and see what kind of tasks I can do as a data scientist, and I'll try to draw a little mind map of that. So I'm a product data scientist, which means that I work with product development teams on a specific feature or specific change to the product. The product usually is some kind of digital product, like an app or a web interface, or something that could be working on your speaker or on your mobile phone, on your computer. And the changes are done by designers and developers. So I, as a product data scientist, help them to determine what kind of changes will be positive for the users that use the product, and what kind of changes would be potentially negative. So what do we want to avoid? Most of my work is doing experimentation and experiment design, or hypothesis testing, the way it's called usually in statistics textbooks. And pretty much I'm supposed to support the team from the very beginning, where they generate hypotheses, figure out what kind of changes, what kind of new features that they want to add to the product they're working on, so that the users use it more and are more happy. Then I help them to determine how can they prove or disprove that hypothesis. So in that case, this will be a design of an experiment. We determine which kind of metrics we define as success metrics, which kind of KPIs we want to move, which ones do we not want to move, so what do we want to not be affected negatively. We also work on maybe slicing the feature and first releasing an MVP to get some learnings and figure out how we can improve it in the next iteration. Then I help developers to define what kind of tracking, so data gathering, we need to do for this feature. Then I help the PM to decide for how long we're going to run it. So this is based on the size of the user base that we have and the metric that we want to affect. So this is regular statistical sample size calculation that we need to do, and there are a lot of things that come into play, like how risky is the feature, how fast do we need results, how much do we need to wait, seasonality, if there's any weekly fluctuations in the metric or monthly fluctuations in the metric. Also external factors like marketing campaigns affect how we want to A/B test the feature. And then while the A/B test is running, I'm going to be doing monitoring of the different kinds of metrics of the A/B test and do an analysis post factum. This is a very brief explanation. What does a product data scientist do? There are many more other areas, so I'm going to actually try to summarize now in a mind map what do I generally do. I defined three main categories categories of work that I mostly do, and I think most of my peers as well. Those are knowledge related category, meetings, because meetings is honestly really big category, and it can grow if you're not paying attention and if you're not saying no enough. And analytics, which is the core analytical work, which is usually what you think of data science work. So for the knowledge area, I split it between acquiring knowledge and sharing knowledge. Acquiring knowledge is a part that's usually done more when you're a junior data scientist or just joined a company. In this area, you can be learning new skills. So you can either learn them through doing different kind of projects, or you can go to conferences, or you can do various courses, either internal or external. You can also read documentation about some technical stuff that's available in the company. And the second part is the documentation reading. And don't be surprised that it's split in a separate part, because whatever you do, if you're data analyst, data scientist, or maybe machine learning engineer, you're going to be reading a lot of different types of documentation. So it can be various strategy documentations about the company overall. What are the goals? What are the metrics? What are KPIs? What are the missions of the company? And what kind of value do they want to bring to the world, because that affects what kind of metrics you assign to the A/B tests. There could be reading related to previous research that's really useful, especially in the bigger companies, to understand what has been done and what has worked or didn't work prior to your experiment. Then there is external research, which is what most of the researchers, like data science researchers or machine learning engineers or machine learning researchers do. That's reading a lot of papers that were provided on conferences. You can also do that as a product data scientist, albeit it may be a little less extensive, but it's really nice to know the know-hows of other different companies and how they work with experimentation. You can read also business goals and strategy. This is not overall strategy, but a more specific goals for a quarter, some like objective key results that your teams that you're supporting need to meet. And then there is sharing of knowledge, and that's usually when you're a little bit further in your career, when you're interested in like sharing your knowledge and mentoring someone. So either you're mentoring junior peers or you're sharing know-how, maybe write articles about certain tools that you build and how they make the workflow more efficient. Then you can share analysis and results of the A/B test or a more specific research analysis. You can do that in form of slides or Google Docs write-ups, or maybe you can write a blog post and share that in internal social networks. Some part of sharing is also done more from like more research-oriented roles, where people find out new concepts or new statistical methods and apply them into the internal tools and then explain how they work. I think that's all related to knowledge. I'm probably missing something, but that's all I kind of could think of right now. Then the next gigantic part is meetings. You are gonna have a lot of meetings if you work as a product-related data scientist. And they split between product team meetings, analytics team meetings, the analytics team that supports this product that you're a part of. Then there is a analytics function meetings, which are more global. Usually they cover all data scientists, researchers that work in the company. And then there are more company-wide meetings. So starting from company-wide, there are all hands announcements, CEO calls, etc. There is also some new joiner stuff that you get to join, like onboarding meetings that I've been doing quite a bit, and it still have a lot of them to go for. Then there is analytics team. This is your immediate team of data scientists and researchers that you work with. Usually it's not that big. It can be from like 2 to maybe 15 people tops. And those meetings are some stand-ups that you have multiple times a week, where you just share what you will be doing the following week. There are planning meetings, backlog grooming, knowledge sharing when you did some analysis and you want to share your results. There are workshops. If you need to learn a new tool, you ask your peers to help you out. There are retros, so taking a look back and seeing what works and what doesn't work. And there are also more like ad hoc meetings, random if the need appears. Then there are more like one-on-ones with either peers that may be sharing knowledge, or you want to bounce ideas from each other. There are one-on-ones with your manager, and there are one-on-ones with other functions if they are in your team. Then there are more like overall analytics function meetings. Again, there was all hands, knowledge sharing, syncs on current work, sharing what works, what doesn't, and sometimes workshops. And then there are a lot of meetings that you do with the product team that you're supporting, and if you're supporting multiple, you will do pretty much double of those. So those are stand-ups as well, maybe multiple times a week, maybe every day, maybe once a week. There are planning meetings on what the team will work on. A lot of teams work in Agile or Scrum methods, so they will plan something for a week or two and then follow that plan. There are workshops as well. Those are more like feature workshops, so trying to figure out what you want to do in terms of like building the new experience for the users. There is analysis sharing meetings, so that's you presenting the results of your analysis or maybe some other relevant analysis for the team. There are ad hoc meetings talking about different stuff with different team members, maybe tracking specifications, maybe more analysis sharing, stuff like that. There are one-on-ones with team members. Those are not mandatory and you don't have to have them, but sometimes you just need to like pop in and have a conversation rather than writing a lot of messages on Slack. There are also retros for the team, which you can join. I don't think data scientists necessarily always join those, but it's really valuable if you want to build relationship with the team and understand their frustrations. There are testing meetings, so you just like sit in a group of people, test your new feature, everything works correctly, maybe test the tracking, stuff like that. There are brainstorms for the feature meetings, and there are then like big feature release meetings where you push the button and start the A/B test. There are also other more like general product team meetings, like you could join demo sessions. Those are usually like bi-weekly. They're teams that work in the same product area, show all the stuff that they did in the last couple of weeks. I think that's all for meetings. That's a lot, and it does take a lot of your time, and over time you learn to understand which ones are valuable, which ones are less valuable. You'll also learn how to make the meeting valuable when you're there by making sure that people are staying on track, making sure that there is an agenda and the goal for the meeting, unless it's like regular basic socializing, which is also very valuable, especially now. And now there is the analytics part, which everyone considers is what data scientists do, but it's not not only what data scientists do. So analytics for product data scientists, I'm not including machine learning engineers here, may be split on 3 different areas. First is data mangling, so that's where you like look at data that you have in a company that's relevant to you. Then there is statistical analysis and visualization and number pool. I don't know how to call that more proper, but let that just be it. So data mangling, which is really important, without going through this phase and working a lot of that, it's hard to be a valuable data scientist and trustworthy one. Those include sanity checking the data, that the numbers are making sense. I remember there was a conversation on LinkedIn between data professionals that like sanity checking is not the best way to name it, but it's really hard to come up with a better name. It's just understanding whether your perception of how the data is generated meets the reality and that the reality is correct to the specifications of tracking, to the actual interaction with the product. You can do that by having your own user account, like playing around the product that you're working on, and then looking yourself up in the databases to see whether what you did is actually what is there. And it's generally like a huge amount of time that you spend doing the sanity check, because of course there are data sets that are pre-built by data engineering teams that are more like company-wide or global core metrics, but there's super often times when you need to work on custom things, and those are yours to check. And without having proper data, it's garbage in, garbage out. Like if your data is garbage, your analysis will be garbage. Then there is data understanding. So that's not only the sanity checking, but also like aligning your own idea of what you should see there with the data that is available there. It's more relevant when the company has like hundreds of tables and different projects, and a lot of them have the same name for the metric, but it may be different metric. Like all those tiny things take a lot of time to adjust to and learn, and they're still like super incredibly valuable. Then there is data cleaning. So when you notice something's off, you need to do that. Then there is data aggregating and preparation. So after you understood the data, cleaned it, then you're gonna be aggregating data over multiple users or multiple regions or whatever. You don't look at like raw logs per event that happens in your product, you need to understand what kind of metrics you want to create and then write a gigantic query to clean it all and accumulate it. And then data pipelining is also a very important part. It's a little bit more on data engineering side, although not very specifically data engineering. So that's maybe if you need to build a dashboard that you want to show to your stakeholders, then you need to schedule daily or weekly or whatever cadence of doing the data aggregation that you prepared previously, or maybe you need it for, I don't know, a model or analysis that you're working on. Oh, I missed out one of the parts. There is also peer review part, which I missed out of the everything you can do in analytics, and that's reviewing someone's code, reviewing someone's pull requests to pipelines or to notebooks or the analysis that they did, reviewing someone's slides, so reading and understanding whether it makes sense, it's clear, it's phrased in a way that will be understood only in the right way, for example. And then there is a review of an analysis, so maybe you're going through a more extensive documentation or someone's Jupyter notebook or R Markdown file and trying to see whether they followed the correct way of doing analysis for the specific use case. That's also some time, and usually it gets pushed down, especially in the very busy teams. So I really appreciate when the team is okay for everyone to take time and do peer review. Sometimes you can't even push a pull request to the master without someone reviewing it, which is really good. Then the part which is visualization and number pools. So those are like someone asking you, how many users did this in the last month? Or how many times did we show this to the users of our app? In ideal world, you have these questions answered somewhere in the dashboard and you can just point the stakeholder there, but we don't live in an ideal world and a lot of those questions are asked for the first time. So there is a little bit of communication, whether they actually need the answer to what they're asking, maybe they're looking for something else, and then there is a little bit of time of actually pulling the data. Then there is visualization in dashboards, so actually building meaningful, understandable dashboards that are providing value to stakeholders. The visualization in slides and decks to explain the analysis, maybe in a more brief way than you would normally do in a whole Jupyter notebook. And then there is a part that's actual statistical analysis of the data. A lot of it is actually outsourced through the tools because that's the easiest part to do automatically. So for example, for analysis of an A/B test, there are usually in the big companies tools that do the statistical analysis for you, especially on the most common metrics and KPIs, because that's something that does not require a lot of human input and understanding. It's a metric that you add that you need to understand whether the impact on this metric from an A/B test was significant or not. So it's very rare actually for someone to do this by hand now, because that's the easiest part to automate often. So this is the analysis of an experiment or an A/B test. Could be done, as I mentioned, automatically, or if it's something very custom or there are caveats to the test, you might need to rebuild the user base and build the metrics based off those users, or you might need to do additional analysis of an A/B test. Then there is a part that is more research analysis kind of thing, which is not attached to an experiment. Usually that's trying to understand the user behavior with a certain feature, or trying to understand the performance of the application in this environment. That requires some statistical knowledge, maybe modeling knowledge and causality if you want to split users based on some characteristics, or see whether one metric is dependent on other metrics, so the causality between different metrics. And then there is also statistical testing. If it's not the experiment that you need to see the significance of, or if the experiment tool that your company has does not provide you an ability to do what you need to do, there's going to be a little bit of hands-on work with that in Python or R usually. I think that's it. That's a super long intro to what a data scientist does. I hope you weren't too bored with that. And now we're gonna go into more lifestyle and I'll show you what I do in one day and not just like generally overall. If you have questions about career in data and analytics, now on my Patreon I have an option that's called mini mentorship, where you can ask me specific questions with context about your specific situation. Maybe you need to choose a learning path in data and analytics, maybe you wonder how you can balance workflows, and maybe you're interested how you can work in tech in Sweden. You can ask me those questions on my Patreon, and once a month I'll answer them there for everyone to see and learn from each other's situations. You can also just generally support me and help me hire a video editor so I can have more videos and more frequently. Thank you and have a nice day.